Hi, everybody. This is going to be a hopefully short little lesson on how you deal with these absolute value statements. And I use that word statement specifically because we're going to be talking about these from two angles. The first is when you're dealing with equations, and the second is when you're dealing with inequalities. So, just as a reminder, when we say the term absolute value, that's indicated by, let's say we have two bars there with a 2 in the middle. This is asking you for the absolute value of 2, and that is going to be a positive number. If I were to say what is the absolute value of -2, that is also a positive number, +2. And that's because when you're dealing with absolute value, you're talking about a number's distance from 0 on the number line. Okay? So absolute value is all about distance, and thus it is always going to be some positive number because distance is always measured positively. Now, the way that shows up algebraically, in its most simple form, is maybe something like this. If I were to say the absolute value of some number x is equal to 3, right? What we're asking for is what number is 3 spaces from 0. And hopefully you recognize there's two answers to that question. There are two numbers that you could count 3 spaces from the number line on, from 0, and end up 3 spaces away. 3 and -3. Okay? So we say that these two numbers, 3 and -3, are solutions to this equation. That is to say, you could plug 3 in for x, you could plug in -3 for x, and they would both end up making the statement say something that is true. All right? So most typically, absolute value equations have two solutions, a positive and a negative number. But as you're going to see, there are different things we can do, different coefficients and constants we can throw into these equations that might change what our solutions are going to look like. So let's do a rundown of all the possibilities real quick. If we're saying the absolute value of x is equal to some positive number, then you have, and I'll use maybe green here, two solutions. All right. If you have the absolute value of x and it is equal to 0, that means you have one solution. And that solution is, at least as it's set up here, 0. And if you solve and you end up with the absolute value of x is equal to some negative number, then you're dealing with a scenario where there are no solutions. Okay? So those are all your possible scenarios when you're solving these absolute value equations. The other thing I'll say about absolute value before, at least equations, before we jump into the inequalities is when you get to a situation where you are solving, and let's say, for example, we had the absolute value of x minus 2 is equal to, we'll call it 10. When you get to a scenario where your absolute value bars are by themselves, like you see here, there's no number being multiplied here on the left, there's no number being added or subtracted on the right, you just have that statement inside the absolute value bars, and then it's set equal to some number. In order to carry on from this point, in order to get rid of those absolute value bars, we have to consider the definition of absolute value, that is to consider the possibilities. If we're saying whatever is in the absolute value bars, in this case x minus 2, has an absolute value of 10, that means whatever is inside must be 10 spaces away from 0 on the number line. And so if we consider our possibilities here, that leaves us with x minus 2 is equal to 10, or the alternative, x minus 2 is equal to negative 10. And once we have that, we would continue from there solving as we normally would, right? We would add 2 to both sides. Over here, these would cancel out, leaving us with x is equal to 12. And over here on the right, we would still cancel out, this time with x being equal to negative 8, right? So you have your two solutions there, as is normally the case with these absolute values. Okay. Now, very briefly, let's talk about what would happen if instead of a absolute value equation, we were dealing with an absolute value inequality. So let's say, for example, we have the same statement, x minus 2. It's still in absolute value bars, but this time we're going to set it less than or equal to 10. This is turned into what we call an absolute value inequality. And the only real difference we're dealing with here is how we handle the inequality sign when considering the definition of absolute value. All right. So we still split this up the same as normal. And we're going to say x minus 2 over here and x minus 2 over here. But what's going to be different is what the sign and the result of this inequality look like. And so we want to consider what is being said here. What we're saying here is x minus 2, whatever value that has, its absolute value is less than or equal to 10. That is to say, whatever inside here is less than or at most 10 spaces away from 0 on the number line. Okay? So when we're considering the definition of absolute value, here's how we consider that. Here's how we account for that. We're going to say x minus 2 is either less than or equal to 10, right? Because those numbers, that leaves for possibilities anywhere leading up to 10. And we're also going to say x minus 2 is greater than or equal to negative 10, right? Because numbers bigger than negative 10 are going to be closer to 0 on the number line. Okay? So that is how you consider the possibilities and the definition of absolute value with inequalities. You just go ahead and take the version of the statement that you're given, and then you take its alternative, meaning you flip the sign and you flip the sign of the number from positive to negative. Or if it's already negative, well, you can't have negative because absolute value doesn't result in negative numbers. And then from there, we would solve as normal. So, same as before, add 2 to everything to get rid of that addition of 2. Boom, boom. And we'd end up with the statements x is less than or equal to 12 and x is greater than or equal to negative 8. If we wanted to graph these, we could, as we would with a compound inequality. Have a negative 8, positive 12. We would put closed circles on both, and we would draw our line in the middle like so. Okay, so now that we have that taken care of, let's go ahead and deal with some practice problems. And so if you're following along in this station's activity, you can go ahead and start on the front side of that paper, where we're considering each of these equations. All right, we have to solve, and then we have to provide a graph for our solutions. So number 1 here is pretty straightforward, right? It says the absolute value of b is equal to 2/3. And remember, if you have absolute value bars by itself like we do here, all we need to do is consider the definition for absolute value. And so if the absolute value of b is 2/3, that means either b is equal to 2/3 or b is equal to negative 2/3. Because both of those numbers are 2/3 spaces away from 0 on the number line. As a graph, all that would look like is have a little number line, have a tick at negative 2/3, have a tick at 2/3, and you put a nice little closed dot on each. All right. things don't get too much more difficult with number 2. If we are looking to solve for this inequality, or rather this equation, all we need to do is isolate the absolute value statement first. And the way we do that here, we subtract 2 from both sides. That's going to cancel out with the positive 2, leaving us with the absolute value of n is equal to 5 minus 2, which is 3. Okay? Now, once you've gotten this far, go ahead and consider your definition of absolute value. We're going to go ahead and split it up into its 2 possibilities. So, if the absolute value of n is equal to 3, that means either n is 3 or n is negative 3. And again, that graph is just going to be a nice little graph with ticks at negative 3, positive 3. Go ahead and put your little tick marks. Going to go down a bit. Now we're looking at this one, which says 7 times the absolute value of d is equal to 49. So this may come across as a little confusing because these absolute value bars do kind of look like parentheses, right? However, they don't behave like them. We can only distribute across parentheses. So if you see some kind of absolute value sign being multiplied by a number, a coefficient on the outside, you cannot handle that with distribution. To get rid of the 7, we're going to have to divide everything in this equation by 7. That's going to cancel out, leaving us with the absolute value of d is equal to 7. And from there, we go ahead, consider our possibilities. Either d is 7 or d is negative 7. We're going to go ahead and finish off with another little graph, nice and easy. Negative 7, positive 7. Go ahead and put your dots. Okay. This next one seems like there's some work to do, but if we consider the definition of absolute value, there really isn't much we can do, right? We're saying the absolute value of r minus 9 is equal to negative 3. And if you remember the conversation previously, absolute value should never result in a negative number because we wouldn't say that any number, any real number anyway, is negative 3 spaces away from 0 on the number line. So we're left here with a situation that has no solution. All right. Let's scroll down here to number 5. To get rid of, or to start solving these absolute value statements, we got to make sure that we get the absolute value statement by itself first. Here we see this negative 2 that's in the way. And again, we can't distribute to get rid of it, so we're just going to divide everything by negative 2. That's going to cancel out the negative 2 until we have the absolute value of 3d. And that's going to be equal to 4 divided by 2, which is negative 2. Now again, you have a situation here that's reminiscent to the situation we just experienced in number 4. Absolute value should never be resulting in some kind of negative number, right? We're seeing that the absolute value of 3d is negative 2. So again, we have a situation with no solution. But I want you to note that we can only make that determination. We can only tell that there's no solution after we've gotten the absolute value symbol by itself, right? So as long as nothing is on the outside, that's when we can look at the number to the right of the equal sign. And if there is a negative, then we can say there's no solution. All right? So those first 5 are some absolute value equations, nice and easy. But if we go over here to number 6, now we have our first absolute value inequality. It says the absolute value of y plus 4 is greater than 12. So what that means is whatever's in here is more than 12 spaces away from 0 on the number line. So we're going to consider our definition. And it's going to look slightly different here because we have that that inequality sign and the number on the right to take care of, right? We're going to say either the y plus 4 we see there is greater than 12, or we'll say y plus 4 is less than negative 12. Because numbers greater than 12 and less than negative 12 are more than 12 spaces away from 0 on the number line. And now that we've done that, we can go ahead and solve both of these. In this case, we're going to subtract 4 from everything. And that's going to leave us with the statement y is greater than 8. and we have the alternative. Crossing these out, we get y is less than negative 16. Let's go ahead and graph. These are our compound inequalities, right? So we're going to have a dash here and a dash here, one at negative 16, which would be the dash furthest to the left, one at positive 8, furthest to the right. For both of these, we're going to be using an open dot this time, representing not inclusive, right? These solutions are not inclusive to these numbers, negative 16 and 8. And if we're saying that y is greater than 8, that means our arrow should go to the right over here. And if we're saying y is less than negative 16, this arrow on the left should be going left. So this should be reminiscent of a OR compound inequality, which we've talked about previously. Okay. Couple more questions here. We're going to deal with this more complex one, which says the absolute value of 2t plus 2/3 is less than or equal to 4. All right? So I'm going to go ahead, I'm going to split that up into its two possibilities. The first is, as it's seen there, 2t plus 2/3 is less than or equal to 4. All right? And we're also going to deal with the alternative, 2t plus 2/3 is greater than or equal to negative 4. And we're going to solve for both. We're going to graph. Usually, we don't like dealing with fractions, and so the easiest way to handle this is going to be, let's go ahead and let's multiply everything by the denominator of that fraction to get rid of it. Let's multiply everything by 3. It's going to happen over here as well. All right. If we do that 3 times 2t, we're going to end up with 6t. 3 times 2/3, that's just going to get us 2. And 3 times 4 is going to get us 12. So we've transformed that inequality so that there's no fraction to worry about. We can do the same thing on this one on the right. 3 times 2t is still 6t. 3 times 2/3 is still 2. And over here on the right, negative 4 times 3 ends up giving us negative 12. Okay? From here, we can go ahead and solve as per usual. First thing we want to do is, let me draw my little line here, add 2 to both sides, or rather subtract 2 because it's positive already. We end up with 6t is less than or equal to 10. Then we can finish off just by dividing everything by 6. And we end up with t is less than or equal to 10/6, which we could write as 10/6, or we could simplify that fraction to be 5/3. And so that's solution number 1. Over here on the right, same 2 steps. We're going to draw our line. We're going to go ahead and say we subtract 2 from both sides. 2's are going to cancel out. We're going to end up with 6t is greater than or equal to negative 12 minus 2 is a negative 14. And then we're going to divide everything by the 6, same as before. And for this inequality, we end up with t is greater than or equal to negative 14/6. We can simplify to negative 7/3. Now keep in mind, when we're dealing with solving inequalities, we typically have to worry about that division property of inequality flipping signs. But in this case, the number that we chose to divide by was not negative, so no signs have to be flipped. That is that. And we're going to finish off by graphing this inequality. Tick mark on the left, tick mark on the right, tick mark on the left is going to be for the negative 7/3 because that's a smaller number. On the right, you're going to have the tick mark for 5/3. Here, our signs are inclusive, so we're going to use that closed circle. And because we're looking for numbers less than the bigger number, but more than the smaller number, our inequality graph is going to look like and. We're going to shade everywhere in between. All right. Last question here. It's a word problem, but it should not be too difficult for us. It says, in a sports poll, 53% of those surveyed believe their high school football team will win the state championship. The poll shows a margin of error of 5 percentage points. We're asked to write and solve an absolute value inequality to find the least and the greatest percent of people that think their team will win the state championship. The first step when you're dealing with these more complex real-world application problems or word problems is to define your variable. And so for this scenario, the thing we don't know as of yet is the actual percentage of the poll, right? We know we see that 53%, but there's a margin of error of 5 points, right? So the actual number could be 5% higher or 5% lower. Next, we want to identify all the numbers we see here to determine if they're constants or coefficients. If I'm looking for my constants, I see 53 right here, right? 53%. I also see this 5 here. So those numbers should show up in whatever equation or inequality in this case that I write. And so in constructing this inequality, if I'm told it has to deal with absolute value, this is how it should look. I know that the absolute value of the difference between whatever my actual number is, my actual percentage, which is X, and 53 should be less than or equal to 5%. Right? Because we know it's 53, but there's that room for it to be as much as 5% higher or 5% lower. So the difference can be, at most, usually indicated by this less than or equal to sign, 5%. And with this inequality, we'll be able to solve and figure out the possible range of our percentage poll. So we're going to go ahead and consider the definition of absolute value here, which means either X minus 53, again, the difference between our actual number and the reported poll number is less than or equal to 5, or X minus 53 is greater than or equal to -5. Okay? All it takes from here is adding 53 to everything. Over here on the left, we end up with X is less than or equal to 53 plus 5, which is 58. Or we go over here to the right, we get X is greater than or equal to -5 plus 53, which is 48. Okay? And those are our two solutions. Where 58 is the maximum and 48 is our minimum. If we wanted to sketch a graph, what that could look like, and I'll do that over here, make a little number line, smaller number 48 goes on the left, bigger number 58 goes on the right. Because our inequalities are inclusive, we can put those big closed dots, and because we're looking for numbers less than the larger one but bigger than the smaller one, we can go ahead and shade in the middle to make it look like an and compound inequality. Okay? And that is absolute value. I'll see you next time.